Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem based on the concepts of linear equations with two variables. As per the problem, the Perfect Paving Company charges $10 per square feet to install interlocking paving stones as well as a $40 delivery fee. So there are two parts to this problem. In the first part, we have to find the greatest area that Andrew can pay for $3,500, and Andrew needs to include 5 cubic yards of sand costing $15 per cubic yard. Total cost of the project. How much will this added cost reduce the area that he can pave with his $3,500 budget? So for this problem, we'll have to use let statements to define the variables we can use to write the equations. So in this problem, we are given the variable cost, which is this $10 per square foot for the stones, and we are also given a fixed cost, which is this $40 delivery fee. So in part A, we should start by defining the variables. Let's assume so C represents the total cost, and X represents the number of square feet that Andrew wants to pave. Now we have to write a linear equation. So we'll start with the general equation. Y equals mx plus b. So there is a general equation of a linear function. So in this case, y is the c value, which is the total cost, because the total cost will depend on the number of square feet that Andrew paves. Now m represents the variable cost. So in this case, that's 10. So 10x plus the fixed cost, which is $40. So this is the linear equation that represents this situation. Now in part A, we have to find the greatest area that Andrew can pay for $3,500. So $3,500 here represents the total cost. So we'll sub in C as 3,500, and we'll have to solve for x. So we have to solve this equation for x. So we have to isolate x. So first we'll subtract 40 from both sides. So the 40s on the right side cancel each other out, and we get, so on the left side we have to do 3500 minus 40, which is 3460 equals 10x. Now we can isolate x by dividing both sides by 10. So the 10s on the right side cancel each other out, and on the left side we get 346 equals x. So this should be the final answer for part A. That means Andrew can pave the greatest area of 346 square feet. So now we can work on part B. So in part B, there's additional cost we have to consider. So that will change our linear equation. He has to consider this $15 per cubic yard cost for 5 cubic yards of sand. So this will change our cost equation to C equals 10x plus 40 based on the cost of the paving stones and the delivery fee plus 15 times 5, because he's being charged $15 for every cubic yard of sand and he wants to order 5 cubic yards. So now we can rewrite this equation. So 10x plus 40. Now we can do the multiplication, 75. And now we can combine the like terms. So 10x plus 115. So this is the new linear equation we have to use to find out how much area can he pave now if he also orders this 5 cubic yards of sand? His total budget is the same. We'll subtract 115 from both sides. So the 115 on the right side cancel each other out, and on the left side 3385 equals 10x. Now we can divide both sides by 10 to isolate x. So now we get x equals, so on the left side we do 3385 divided by 10, which is equal to 338.5, and the unit is square feet. So this is the new area he can pave if he takes into account the cost of the sand for the same budget. Now we have to calculate how much the area will be reduced. So for that we'll do 346 minus 338.5. So we'll have to subtract these values. So I got 7.5. So that means his paving area will reduce by 7.5 square feet. So this should be the final answer for part B. So I hope you'll find the video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.